Hello, this is Mr. Agbamu Idanogwene. I'm here to teach you topic in mathematics under differentiation in calculus, which is maximum and minimum point. And all I want us to achieve in this class is to find how to get the turning point of a function. So if you are asked to find the maximum or the minimum point of any function, I'm going to demonstrate it for you how you can do it. So I want you to understand what we mean by maximum and minimum point. Let's take this example. Let's see. So if you have a function, for example, let's take y is equals to, let's take y is equals to 3x squared minus 5x plus 7. Okay, so this is a function, for example. So you can see that this function has a minimum point. You can see the curve. Let me show you well. You can see how the curve goes. So in this curve, you can see that the curve is turning downward. So this is the minimum point of this curve. You can see how it started coming down. Let me start from this 15, for example. You can see how it's dropping down, 14, 12, 11, just like that, till it get to the minimum point. Then it rises up again, just like that. So this value is very, very important when it comes to analysis of a function in mathematics. So this is the minimum point you may be asked to find. So if this function, let me change this place to negative. So if I have minus 7, you can see that the minimum point has gone down to around minus 9. You can see it. So just like that. Then if this value is, let me change this place. So this place I have 3. Let me turn it to negative 3. So you can see that the value has changed. See, the curve has changed now. So this curve no longer have a minimum, it now have a maximum. You can see as the curve is rising up from minus 16 to get to the highest point here, which is the maximum point, then to start dropping down, which is very, very important. Then let me change here to, let's say this place is positive. So you can see how it goes. From, let's say from minus 3, it rises up till it get to the maximum of this point around 9, then it started dropping down. So this is maximum value. So this is what I want to demonstrate for you, how you can calculate maximum and minimum value of a function. So you may be asked to find the turning point, which can be maximum or minimum. So depend on the question how it comes. So let me start with this example I have here. For example, you may be asked to solve something like this. Let's say you are asked to find the minimum value of this function. Let me just put it down. So let's see. So example now. So you may be asked to, this is just a simple one I have here, find the minimum value of the function. So let's take this as the function. Let's say y is equals to 2x squared minus 4x plus 1. So let's say you are asked to find something like this. So how do you get the minimum value of this function? So before I demonstrate this, let me just give you the steps of how you can get the minimum or maximum value of a function. So let me just put them in 3 different steps. Let's say steps in finding the turning point. Let's call it like that. step in finding the turning points of a function. Okay, so they are just in 3 basic steps. Okay, let's start with let me come down. Let's start with step 1. Step 1 is to find the y dx. So find the y dx. That is the first step. So after finding the y dx, then set it to equal 0. So when you differentiate the function, then set the function to be equal to 0. That is the first step. Then the second step, which is step 2. So after setting it equal to 0 now, you need to solve it so that you can get the value of that. Then solve. Okay, let's put it as first step. Set it equals 0 and solve for x. So that is 1. Then the second step is you find the second derivative. So you find the second derivative, which is d square y. D square y now divided by the x square. So find this one. Then this one will now lead on to the third step. So when you find the second derivative, then we have 3 conditions in third step. In the third step now, let me number them. Condition 1. So let me just copy out this. So if this one, if it's okay, we need to use this operator greater than. So if that one, if it's greater than 0, then if it's greater than 0, then the function has a minimum. It has a minimum value. So this is the first condition in step 3. So after you have differentiated this function the second time, you find the second derivative, then check your result. If your result for the second derivative is greater than 0, then this function has a minimum value. Then you can now know that what you are solving is minimum. For example, this question says we should find the minimum value. So I will demonstrate everything with this step so that you understand what we are doing. We have some cases whereby the function may have both minimum and maximum points. So you may not actually know which of the value will be maximum or which of the value is minimum. So you check with the second derivative, which is this. But if this second derivative now, so if the second derivative, let's see. So if the second derivative now, which is this, so if this one is, let's put it there, if it's less than, so if it's less than 0, then if it's less than 0, that means the function has maximum. It has maximum value. So that is one thing you should take note of. Then the last condition, though I'm not going to explain that here, that one is a point of inflection. So that is the third condition, but we don't really need that one for now. So if it's equal to 0, So if the point of inflation is equal to 0, if the second derivative is equal to 0, so the function has point of inflection. So we are not doing point of inflection for now. So that is what I just wanted to know. We are not doing this for now. So this is our major target, minimum and maximum point. So these are the steps in order to calculate the maximum or minimum value of a function. So I want you to take note of this. It's very, very important. So with these steps, let's use it to solve this question. Let's see what we are doing. So if you are to check for this function, for example, y equals to 2x squared minus 4x plus 1. If you want to check to get the minimum value, which is the turning point now, how do you get the exact point for the minimum value of this? So the first steps here, we say find the y, the x. So if I differentiate this function now, all I just need to do is the y dx. The y dx will be equals to what? You know your rule for differentiation, 2 times 2, which is 4. We're going to have 4x. So you are through with that. 4x minus, then differentiation of 4 minus 4x is going to give us 4, then plus 0. So that is all. We have done that. Then the next step we say set it to 0. So I will still tell you why we are setting it to 0. I will demonstrate everything later. Let's see. So set it to 0. I'm now going to have 0 is equals to 4x minus 4. So that is that. Then when you set to 0, now I said solve for x. So let's solve for x. Now if you solve for x here, you see that 4x, that is x, is now going to be equals to x is equals to 1. X will be equals to 1. So you can see it. So that is the value for x. Then the next step is by getting x equals to 1, you are not sure if the function has a minimum or a maximum value, except you do the second differentiation and check your condition if the second derivative is greater than 0. So if I differentiate it the second time now, let's see. By differentiating it the second time, you are going to get, so this second differentiation, you are going to get 4. So 4 is the second differentiation. So now you can see that in your condition, the 3 conditions we have here now, d square y over dx square is greater than 0. You can see equal to 4. That means it's greater than 0. For it to be greater than 0, that means we have a minimum value. So we use this second derivative to check our differentiation. That is all we do. So now that I've differentiated it, you can see that the value I got is greater than 0, which is 4. That means this function has a minimum value. All I just need to do now, I will now say therefore, just conclude now. So therefore the minimum now, so therefore the minimum value of the function is, so that is all for now, is, let me position it well, the minimum value is at x equals to, so you know you found x equals to 1. At x equals to 1, then let's find for y. At x equals to y will be equals to what now? At x equals to 1, y will be equals to, now come to your function and substitute. Y will be equals to 2 brackets 1 raised to power 2. Just substitute the value of this 1 you got into this position of x. That is all. That's all we are doing. Minus 4 open bracket 1, then plus 1. then what do we have as a value for x now? So if you, sorry, your value for y now. So when you solve now, what are you going to get? So we are going to have y is equals to, so this is 2. 1 raised to the power 2 is 1. 1 times 2 is 2. 2 minus 4. 2 minus 4 plus 1. And that will give us what now? So that is going to give us y is equals to minus 2 plus 1 is going to give us minus 1. So these are your two answers. These are your two answers, and that is all. Then you can get, so these are the values. So the minimum value of this function is x equals to 1, y equals to minus 1. So if you want to put it in terms of your coordinate now, you can just say the turning point. So the turning point now, the turning point of the function, turning point of the function is, you have your 1 for x, then minus 1 for y. So that is all with the question. So that is all. There's nothing so special about it. So this is how you get your maximum and minimum value of a function. The function will be given, take note, differentiate the function first, which is find the y dx, then set it equal to 0 and solve for x. Like what I've done here, x is 1. So the value you get for x here is your value for x. Then to be sure if you have a minimum or maximum value, differentiate it the second time, which is d squared y over dx squared equals to 4. So when I differentiated this function the second time, I got 4. And what is 4? 4 is greater than 0. So we have a minimum value. So with this, you can be sure that this function is going to have a minimum value. Then what will now be this minimum value? So at x equals to 1, which is the value you got from setting the y dx to 0, substitute into the function, you will get your value for y. Y is equals to minus 1. So the turning point of that function is going to be 1 for x, comma, minus 1 for y. So that is all. So if you want to demonstrate this to understand this function, that means if I plot this function on a graph, so I'm going to have a minimum value, the graph is going to curve downward, and at the minimum point, at the turning point on which the graph turns round is going to be 1, comma, minus 1, and the gradient of that curve, when the gradient is 0, that is when I'm going to achieve this turning point. So let me demonstrate it here so that you get what we are talking about. So if I remove this, so the function we just plotted, let me impute it, which is 2x squared minus 4x plus 1. So 2x squared minus 4x plus 1. So this is the function we just plotted. You can see it. So by plotting it, you can see we have a minimum value. Then let me create a point so that you get what we are talking about. So if I create a point on this curve, let me create a line on it. So let me use a tangent. Let's use a tangent. To get the gradient on this line, we need a tangent. So we need a tangent on this. So let's take this as a tangent. Then let's get the gradient of that line. The gradient, which is the slope, is the same thing as, so this is gradient now. So you will discover that when this gradient is 0, the gradient will be 0 at this point, at the minimum point. That is why we say anytime you differentiate the y dx, the y dx is also gradient. Anytime you differentiate it, set it equal to 0. So when you set it equal to 0, you will get your value for minimum or maximum point. At minimum or maximum point, gradient is always equal to 0. So that is what I want you to understand here. So if I move this point, let's move this point, you will see that when gradient m is equal to 0, you are going to achieve your minimum point, and this minimum point, the value is going to be x equals to 1. You can even see it, x equals to 1, y equals to minus 1. That is the minimum point. So that is all we are talking about. See, as I'm coming down, you can see the graph is changing. See, the gradient is changing. You see that at m equal to 0, that is when we are going to achieve our minimum point. So you can actually do that without plotting your graph. You can see it's 0.05. Now let me move it up a little. See, 0.01, 0.1, so 0. You can see now, very important. And you can see your point now. This is the turning point now. X is 1, y is minus 1, and that is the point where gradient equal to 0. But if I move up, it's a turning point I've changed, because this is not actually the turning point. The turning point is the point at which gradient is equals to 0. So that is that. So you can see it, when gradient is 0, you have achieved your turning point. So that is why we say when you differentiate, set the y-ds to 0. So it is only when the y-ds is 0, that is when you can achieve your maximum or minimum point, which is also known as the turning point of a function. So that's all for now. So in my next video, I'm going to do 1 or 2 examples and give you some questions to practice. And that is all for maximum and minimum value of a function. Thank you for watching. Have a nice day.